Okay, so here I am on my Jupyter Notebook, and you can download a Jupyter Notebook by searching online how to download the Jupyter Notebook, and you can follow the tutorials to download a Jupyter Notebook. Okay, so what we will do, we will first start with importing the libraries, then we will load the data, we will understand what data we are working on, and then we will follow the feature engineering, then we will see how to select features, we will do exploratory data analysis like data visualization and data analysis, and we'll perform feature engineering, and then we'll see how to select the features from the correlation of the features. And you don't need to have any kind of experience with pandas, or although you can have a look if you want to in detail, but you don't have to be expert in all of these. If you are just this is just a beginner project, you can also modify it and put it on your resume and make some changes. And what you can do, you can save this model and simply deploy it over a website. Okay, so I will talk about deployment later on. But before that, let's walk through. Let me make you walk through this project. So first of all, we are importing the libraries. First, we are importing the NumPy as NP, and we are importing NP as alias, pandas as PD. PD is also alias to short form a name. Plotly is another great visualization library, but I rarely use it. I don't want to use it for now, but in future you can use it. Plotly, just wanted to show you. Seaborn, which I'm going to use it here, and Matplotlib is also a visualization library that I'm going to use over here. And this Matplotlib inline tells you to use Matplotlib in the backend. Okay, it's kind of tells Matplotlib to choose to plot the images in the backend. Use the Jupyter Notebook as a backend. Okay, so first of all, this is the learning thing. So we will load the data from the scikit-learn library. Scikit-learn library is a famous library for machine learning. So we will load the data sets from load Boston, which is a Boston house price prediction. We'll make Boston house price prediction. So we want a data set of that. Okay, then we instantiate our load Boston, and then we take out X, which is the data. I will tell you what is X and Y over here, and Y, which is a load Boston.target. In our previous tutorials in the introduction to machine learning, we have a talk about X and Y variables. X variables is the independent features which we use to predict the model, and this is the Y, which is the target variable, because it's unsupervised, so we know what our output is. We know what our output label Y is. Okay, so we will be given this, and X, Y is the target variable, which will be in this case is the sales price, and this is the features. Okay, and then I call pd.data frame, and it constructs a data frame, and we give X, which is the features, and we give the name of the columns dot feature names. There is a dot attribute dot feature names to get the names of the columns automatically. Okay, and then we make one column. Here we are making one column which is a sale price. We are making a sale price, and then we are making it Y over here. Okay, Y means the load Boston dot target. Either you can make this also like this, either you can make this also, it's just the same. Okay, Y is just a target variable, and if you just run this, now you can see this is the data frame. Here you have a crime rate per capita. That let's see the column distribution. So just first see, let me show you what we have done. These are the X variable till LStat. These are the X variable, and this is the Y variable that you use to predict. And you may think, yeah, I use 24.0 means 24.0 is the dollars is just the price of the house. No, the price of the house is given 24.0 $1,000. Okay, so you can just we will see the whole thing just in a second. Okay, so this is the data frame that we constructed. Okay, so now let's take a look at what data we are working on. So there are 506 rows, and there are 30 numeric and categorical columns, and with the median value attribute 14, which is our target variable. Here I'm given is a sale price name, but you can give as a median value. It's usually the target variable. Okay, so here is the column name, is the crime is the per capita rate, then proportion of a residential land, proportion of a non-retail business, NOx, age, what's the proportion, average number of rooms per dwelling, etc. You can rate over here. And the last, which is the favorite, the target variable, which is the median value of which is the sales price in this case, is at $1,000. So $24,000 $1,000. Now your dream has gone out, I think so. Okay, so you can read it over here. Just you can use .dcedescer because it is available in the scikit-learn, so you have this kind of thing to see the information about the data set. But in real world, we will work on real world data set, so you will see how you download, how we process, etc. Okay, so let's understand a little bit more about the data. We look at the shape of the data, which is 506 rows and 14 columns, means rows and then columns. Then your .info tells us the information of your data, which is non-null values, means what are the data types and is there any null values into that. Null means missing values into that column. Okay, and all the data types are float, what is the memory usage, etc. Okay, and let's .describe will tell you the mean of that particular column, the standard deviation, the minimum, 25% of that, 70% max count, etc. Okay, so we had seen what data we are working on. These are the features, which is the x variable, and this is the target variable, which is y, which is a supervised learning problem, as we can see over here. Okay, so let's take a look at the null. You can use data.isNull.sum, and you can see over here that we have the 0, 0, 0 all the way, and then we can plot a pair plot, sns.pair plot, which will plot all the things which with respect to every feature. So you can see over here that we are just plotting the pair plot. You can see, but we do not get a lot of information from this pair plot because it's very kind of small and we cannot see what data is it pointing on, etc. Okay, so we have to definitely take care of that to check more visualization that I made. Okay, just wait for a few seconds, then it will show up. Okay, so it plots and we are unable to see this kind of thing, and we are unable to see, so it's very hard to see this. So what we do, let's take out and let's take out the inferences from the sales price, which is the target variable. Let's do some analysis. So we plot a distribution plot, and you can see over here this is a little bit skewed. We are seeing over here this positive skew, but here we can add some transformation. So what's the skewness and what's some kurtosis? So here we have 1.108098 and 1.495197, which this will help us to find outliers, and outliers are those who are far away. Let's say that you are working on age. Okay, so age is 20 years old, 50 years old, but let's say 150 years. This is the outliers. Okay, these are the outliers. Okay, those who are exceptions of the data frame. Okay, so we have to take care of this, but before that, let's see some relationship with each and every column. One, you have taken two columns, so you can try different columns. So there is little bit crime, there is the sale prices very high. When there is lot more crime, there is sale prices very low. Okay, and what's the age, you can also see, and you can see over here 100 years old has been sold in a smaller rate, and 20 years old has a little bit higher rate, and you can see the data visualization over here. Okay, and you can see over here that I've imported scipy, which is again the like numpy. I'm just taking out the norm and the skewness. So you just plot a distribution plot for seeing this kind of thing, means for normal distribution. If you know about normal distribution, you are just plotted the normal distribution, and this is your actual this black line, and you have this blue line, so you have to transform it a little bit. So your mu, which is mean is 22.53 and sigma is 9.19. okay, so these are some, if you know about Python, you should know about these kind of for formatting, etc. Okay, and this is the QQ plot, which will help us to see the quantiles, which is order values. You can search more on the internet or go on Wikipedia to learn more about this. But our main focus will be this sales price, means distribution plot. Okay, so let's run this. Let's add a log. Let's transform our sale price to a little bit more accurate. So now you can see over here that this is skewness is over. Now we have just applied a transformation over here, log 1p, and it's now good. Okay, to avoid outliers. Okay, and this quantile is also removed. Okay, so data correlation. What are correlation? First of all, correlation is the relation between features. Okay, so if it is 1, then it is positive correlated, then it's -1, very negatively correlated. You can search more on the internet about it because it's not a statistics class. So you see over if the diagonal is 1, all the features are perfectly correlated. Okay, so how do we select the features which are highly correlated? Okay, the features how we select, if we have taken the absolute value of the sale price and we are taking the highly correlated feature from this statement, and there is 12 feature that we get that is highly correlated. You can choose this, but I'm not going to choose. You can either delete the rest of the columns except these 12. Okay, and let's just start with model building. So you just import train test split, and train test split simply divide your data into training and testing. Means let's say you have 80% of the data, so sorry 100%, so it will take 80% for training and 20% for testing, and you just drop because you don't want X to be sales price and Y to be the sales price. Okay, and then you test size, then the random state will tell you the means every time you run the data should not be changed. Okay, so if you run this, now let's take a look at the shape. 404 and 13 columns for training, and 402 for testing, and 401 for labels, and 102 labels. Okay, so let's start with let me make one more, little bit more so that it should be clearly visible. Okay, so you just import from scikit-learn, which is a linear regression, and you just instantiate it, and then you fit the model xtrain and ytrain, which we have used for training, and ytrain and xtrain are these are the input, and this is the y target variable. And then if you run this, now it's instantiated. Now we can make prediction. Okay, so you can see over the actual label, because we know what y test 0, because this is actual label, and this is the prediction, which is 3.36 is a predicted value from the model, and 3.21 8875829 etc. is the actual value, which is little bit different from this, but it's performed very good in terms of linear regression, as we have seen so far. Okay, now if you want to check the accuracy, for checking the accuracy we have seen a cost function. You can run this and MSE, mean square error, and let's say if you want to see MSE, there is 0.035, which is good. And if you want to take the RMSE, the square root, you just np square root, and we are getting the RMSE, so you can just print it out, RMSE. Okay, and you have seen it's pretty much good. Okay, you will learn more about how we can improve this by using XGBoost, bagging, boosting, etc. later on. Okay, now we have done our full prediction project. The code will be in my GitHub, which is in the description box below. There is a lot more projects which is available in computer vision, natural language processing, which you can take a look if you want to my projects. Okay, so now I think I have not coded just now because it will take a lot of time, so I just written up and just annotated each and every line of statement. Okay, so if you have any kind of problem, then search on internet, because you have to master Google to if you have encountered any kind of problem. And in the next tutorial, we'll be talking about regularized linear models, which we'll talk about lasso and ridge, which we'll also use in this to check as a lasso and regression and a ridge regression. Okay, so let's get into the next section. Okay, so now we have talked about linear regression, and we have made one project. Now it's time for getting into the regularized linear models. Okay, so if you remember that we have pointed out some problem which is overfitting, which we have pointed out earlier. Okay, so how does overfitting happen? Let's say if your model has learned too much, so let me draw one x and y plane, and let me draw some data points. Okay, so these are the data points, and let's say you have a complex model, which is a complex function which maps your input variable to output variable. So you just make the complex function like this, which is touching each and every line. So let's say a new example comes in and it's making a bad prediction. So you can see over here it learned too much onto the training data which are in trained, and it is very going bad. It is not generalizing well onto the new examples. Okay, so that's called overfitting. If your model working best 100% accuracy onto training and working worse on the validation accuracy, then your model is likely to fit overfitting. Okay, so how it is caused? Let's say you have a lot of features and you let's say 1,000 features, and so it will learn obviously the complex functions, and then it will perform very bad. Okay, so for that we have some solution, and the solution are either you reduce some features. This is, you can do this. Another thing what you can do, you can this is the same as like this, regularization. In simple terms, regularization is just eliminating the features that are not useful. Okay, so it is just equals to this, so we give another name which is called the regularization. So let's see some of the regularization techniques. So the first one is lasso regression. So let's see a lasso regression. So what is lasso regression? Lasso regression is a regularized linear models. What we do, we just add a simple term, a simple regularization term at the end of the cost function. Let's say this term, lambda 1/2 I equals to 1 all the way down to the n theta squared I. Okay, so this is for a ridge regression. This is for a ridge regression. Okay, so this is for ridge regression. I will talk about lasso just after this. Okay, so just you add this at the end of the cost function. So your now new cost function will become like this: 1/m plus I equals to 1 all the way down to the m theta transpose xi. This is the model predicted minus yi squared plus your regularization term, this one I equals to 1 all the way down to the n theta squared I. Okay, so you can do like this. Now let's understand what it's doing. It is just let's say you have some features, which is the, let's say, the size of the house, let's say the price, let's say the number of fans, number of bedrooms, and a number of a grass. Okay, number of grass. So you can see whether this seems to be a less important feature. So it will simply make the theta, means the parameter feature, means the feature weight of this column, to be 0. Okay, so it simply penalizes or closer and closer to 0. In ridge regression, it makes the feature weights closer and closer to 0. Okay, so what is doing, it is whatever the less important features are, is just penalizing the theta of that, and the theta is used to make prediction, and let's say theta times the number of a grass equals to prediction. So let's say it's a very small. Okay, so it is just penalizes your theta. Okay, so that's ridge regression is doing, just penalizing or eliminating the, or by how it eliminating, just making theta to be equals to 0. Okay, but in ridge regression it is making closer and closer to 0. But in case of lasso regression, it is simply in case of lasso regression, I'm talking about lasso regression, it's whatever the less important feature are, it simply make the theta 0. So whatever, let's say theta times the number of a grass, so theta equals 0 times the, let's say 7, which is equals to 0. So these features is eliminated. So that's a lasso is very strict. Okay, so these two, and you use L2 norm. In that case, in ridge regression you are using L1 norm, but in lasso you are using L2 norm. Okay, just adding the regularization term, which is like this, at the end of the cost function, I equals to 1 all the way down to the n, the absolute value I, and 1. yeah, this one. Okay, so but one more thing that you can see over here, that we do not penalize our theta 0, which is the bias term, which is only the bias term. So we don't want to penalize this, so we start with I equals to 1. So we start with I equals to 1 rather than starting with I equals 0. So we do separately all the things. Okay, so what we do, we just we just start with the I equals to 1 all the way down to the j, which is the theta. We separately do 0. Okay, I think it's very clear. Let me make you clear what I'm saying. I'm saying that you do let's say for theta 0, j of theta 0, you do separately this. You do separately this without the regularization term, without. Okay, but for other thetas 1 all the way down to the j, you do add the regularization term at the end of the equation, and then you separately update this also, this theta 0, and you separately update this theta 1, and you just take this as a gradient of this theta for theta 1 all the way down to j, and this gradient, this the gradient of this cost function theta 0 for updating of theta 0 or getting the best theta 0. Okay, so you do not want to penalize, because only the bias term, you don't want to penalize this. Okay, so I think that is very clear to you, and again, for recap, regularization is just penalizing or eliminating the less important features by making the parameter weights equals to 0. Okay, now I hope that's pretty much clear. Now I hope that is very clear, and in the next tutorial we'll be working on to last regression, largest regression, which is the, now we'll start with classification, which will cover logistic regression as the same as a linear regression, but it's a classification, not regression. Okay, so let's I will be happy to see you in the next section.